To effectively prepare for the Illinois electrical exam, focus on the current edition of the National Electrical Code. While exam questions might reference the 1996 code, it's crucial to answer those questions based on the provisions of the 2002 National Electrical Code. This is because the electrical industry operates under the most up-to-date safety standards and practices, and the exam aims to assess understanding of these current standards. To obtain a copy of the 2002 National Electrical Code, consider purchasing it from organizations such as ICE, the International Code Council, or NFSA, the National Fire Sprinkler Association. These organizations typically offer the code book directly or through their online stores. Studying the 2002 National Electrical Code involves understanding its structure and key articles. The code is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Firstly, familiarize yourself with Chapter 1, which covers general requirements, definitions, and rules for electrical installations. This chapter lays the foundation for understanding the rest of the code. Secondly, delve into Chapter 2, which focuses on wiring and protection. This chapter covers topics such as overcurrent protection, grounding, wiring methods, and conductor requirements. Pay close attention to articles related to conductor sizing, raceway fill, and box fill calculations. Thirdly, explore Chapter 3, which addresses wiring methods and materials. This chapter covers various types of wiring, including rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Understanding the proper applications and installation requirements for each wiring method is essential. Fourthly, examine Chapter 4, which covers equipment for general use. This chapter addresses topics such as switches, receptacles, luminaires, appliances, and motors. Pay attention to the requirements for grounding, bonding, and overcurrent protection of electrical equipment. Fifthly, review Chapter 5, which addresses special occupancies. This chapter covers electrical installations in hazardous locations, healthcare facilities, and other specialized environments. Understanding the unique requirements for these occupancies is crucial for ensuring safety. Sixthly, study Chapter 6, which covers special equipment. This chapter addresses topics such as electric signs, swimming pools, and solar photovoltaic systems. Understanding the installation and safety requirements for these specialized systems is essential. Seventhly, explore Chapter 7, which covers special conditions. This chapter addresses topics such as emergency systems, standby power systems, and fire alarm systems. Understanding the design and installation requirements for these systems is critical for life safety. Eighthly, review Chapter 8, which covers communications systems. This chapter addresses topics such as telephone systems, data communication systems, and cable television systems. Understanding the grounding and bonding requirements for these systems is important for preventing interference and ensuring reliable operation. Ninthly, study Chapter 9, which contains tables and examples. These tables provide valuable information for conductor sizing, raceway fill, and other calculations. Understanding how to use these tables is essential for accurate electrical design. When studying the 2002 National Electrical Code, focus on understanding the fundamental principles and concepts behind the code requirements. Don't simply memorize the code rules, but strive to understand why those rules are in place. This will help you apply the code effectively in real-world situations. To understand overcurrent protection, consider Article 240, which covers overcurrent protection devices such as circuit breakers and fuses. The purpose of overcurrent protection is to protect electrical circuits and equipment from excessive current that could cause overheating, fire, or damage. Circuit breakers are designed to trip and open the circuit when the current exceeds a predetermined value, while fuses are designed to melt and open the circuit. The size of the overcurrent protection device must be carefully selected to match the ampacity of the conductors it is protecting. To understand grounding and bonding, consider Article 250, which covers grounding and bonding requirements. Grounding is the process of connecting electrical equipment and circuits to the earth, while bonding is the process of connecting metallic parts of electrical systems together to create a low impedance path for fault current. Grounding and bonding are essential for protecting people from electric shock and for providing a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. To understand wiring methods, consider Chapter 3, which covers various types of wiring, including rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Each wiring method has its own advantages and disadvantages, and the selection of the appropriate wiring method depends on the specific application and environmental conditions. Rigid metal conduit provides excellent mechanical protection and is suitable for use in hazardous locations, while electrical metallic tubing is lightweight and easy to install. Non-metallic conduit is corrosion resistant and is suitable for use in wet locations, while cable assemblies are flexible and can be easily routed through walls and ceilings. To understand conductor sizing, consider Article 310, which covers conductor requirements for ampacity. The ampacity of a conductor is the maximum amount of current it can carry continuously without exceeding its temperature rating. The size of the conductor must be carefully selected to match the load it will be serving. Factors such as ambient temperature, number of conductors in a raceway, and type of insulation must be taken into account when determining the appropriate conductor size. To understand raceway fill, consider Chapter 9, which contains tables for raceway fill calculations. The raceway fill is the percentage of the raceway's cross-sectional area that is occupied by conductors. The National Electrical Code limits the raceway fill to prevent overheating and to ensure that conductors can be easily pulled into and out of the raceway. The raceway fill calculation takes into account the size and number of conductors in the raceway, as well as the type of raceway. To understand box fill, consider Article 314, which covers outlet boxes, device boxes, and junction boxes. The box fill is the maximum number of conductors that can be installed in a box. The National Electrical Code limits the box fill to prevent overcrowding and to ensure that connections can be made safely and reliably. The box fill calculation takes into account the size and number of conductors in the box, as well as the size and type of box. In addition to studying the code book, consider attending electrical exam preparation courses or workshops. These courses provide valuable instruction and practice questions to help you prepare for the exam. Many organizations offer these courses, including trade schools, community colleges, and professional associations. When taking the electrical exam, read each question carefully and make sure you understand what is being asked. If you are unsure of the answer, eliminate the obviously wrong choices and then make an educated guess from the remaining choices. Don't spend too much time on any one question, but move on and come back to it later if you have time. Remember that the goal of the electrical exam is to assess your understanding of the National Electrical Code and your ability to apply it to real-world situations. By studying the code book, attending exam preparation courses, and practicing answering questions, you can increase your chances of passing the exam and becoming a licensed electrician. Remember to focus on the 2002 National Electrical Code, even when questions reference the 1996 edition. The 2002 edition represents the current standard for electrical safety and installation practices. Good luck with your exam preparation.